Oh, we are reviewing for your test that is tomorrow, individual. Who's going to be gone tomorrow because of Courage Retreat? Just a couple of you? Okay, so you'll have to make it up Thursday. Wednesday is your partner test, and we're going to use the scores that you get on tomorrow's test to match you up with your partner. So the top scores will go together, et cetera, all the way down the line. Huh? No, we're going to do it this way. We're all doing it this way. Okay, so you want to score as well as you can.
Why wouldn't you have the highest with the lowest?
Because then the highest does all the work. No. Okay, guys. What is the fundamental theorem of calculus? What is the derivative with respect to x of the antiderivative from some constant to g of x of f of t dt? I love these problems because I know they're going to be quick and easy. When I see a derivative with an antiderivative, they just undo each other. Do you remember what you do? You take this and substitute it in for t. So I get f of g of x times the derivative of the upper limit. There's a lot of this on the test. Okay? So Joe, how do I do this? Can you see it okay or not? That's an x cubed. You can't find the antiderivative of the log of t squared plus 1. It can't even be done as far as I know. I have no idea how to do it. But we've never done anything like that. So when you look at it and say, we didn't do anything like that, you're right. We've done these, though. If you've done your homework, we've done these. Just substitute that in. So it's the log of x cubed squared plus 1. Am I done? Times the derivative of x cubed, which is 3x squared. Now you remember how to multiply that out with exponents, because you're going to have to simplify. And they were kind. They didn't put x to the 5th here as an option. They could have. But it's x to the 6th plus 1 times 3x squared. So which answer is it? It's E. Could it be easy to get C without thinking? Yes. Make sure you take the derivative of the upper limit. These are what I call distractors. And then they have 2x cubes. If you can think of the upper limit, you might look for this one and this one. This one, they took the derivative of the log and then substituted the x cubed in. Okay? Here's another one. These are short little problems. This one's a little tricky. And it's tricky because of the wording. Let's see if I can make it a little bit bigger. And it says, here's a graph of a function, and A1 and A2 are the positive numbers that represent the area. What is an integral? Because we're going to ask here for an integral. What is an integral from A to B? It's the signed area. So you have to understand what they're saying. They're saying these A1 and A2 are simply numbers, like 2. That's all it is. And it says, they represent the areas of the shaded regions. Then I would like to find the integral, the signed area, from -4 to +4, minus twice the signed area from -1 to 4. So I want to add up the integral, the signed area under this curve, and what's going to be true about the area here, the signed area? It's negative. So it's going to be A1. This is the first integral. I'll put a parenthesis there. And then, is it plus A2 or minus A2? Minus A2. It's really not that bad if you understand what they're saying. That's the first integral. The second integral is 2 times, and I just want the integral from -1 to 4. They could have gone 4 to -1 and really thrown you a loop there. But it's -1 to 4, so that's what? Minus A2. Do you guys see what's negative? This is a positive number. If they said A1 and A2 are numbers that represent the integrals or the signed areas, then I would have to look at this problem very differently. So which one is that one? Careful. do the algebra. A lot of you guys like to skip the algebra, but don't do that because it's not a smart thing to do. Plus 2a2. And this will give you a1 plus a2. So let's see. Algebra. Make them x's. X and y or something. If that makes it easier. Now, the multiple choice questions are online, and the solutions are there too. That's the regular fundamental theorem of calculus. So let's just do a quick hopefully a quick review, and then we can look at some problems. Well, there are 5 things that we have to think about in this chapter. The first one is the fundamental theorem of calculus, which says that the antiderivative from a to b of little f of x dx is equal to any antiderivative evaluated at b minus any antiderivative evaluated at a. That's the fundamental theorem of calculus. I call it the evaluation theorem. Okay, that's the first, to me, that's the first half of it. And it's really, those antiderivatives is still the area under the curve. I was looking for my notes, but that's okay. So why would the area under the curve be equal to the antiderivative evaluated at the endpoint? I mean, I can prove it, but it would take a while. So that should be rather strange. So when we do average value, that's what will bother you about average value. The second fundamental theorem, this is part 1, and FTC part 2 says, and we just did that one, the derivative with respect to x of the antiderivative. Well, if we just do a to x, where x is just any variable, and it's f of t dt, what's this one equal to? F of x. You see this, if you'd worked on any of those free response questions, you saw that theme over and over again.
So that's dt or something?
It does. They will not write it incorrectly. If you don't write the dt, they will not penalize you. It doesn't matter. I don't know what you mean by indicator. Well, when we do areas and volumes, you're going to see that this makes a big difference in how you set up and solve a problem. So to me, that's an indicator when you're doing problems. But on the exam, you'll see this. It'll be mathematically correct. So then, what is the derivative with respect to x of a? And let's go to some function, g of x. We just did this, right? These just undo each other. So the derivative of an antiderivative is just the function back itself again. So this is f of g of x times g prime of x. Don't forget the g prime of x. That's the thing I'm concerned about. And if you were to integrate this, you would have some function with a g function in it. And when you go back to differentiate that, you have to remember the chain rule. That's the reason why that's there. Is that okay? Yes? No? Just want to make sure I cover everything. Okay? An integral from a to b is equal to the signed area, could be negative. And what's the difference between distance and displacement? If you remember, we found the area under a velocity curve. Sorry, my picture's not very good. And this was the rate times the time, and that gave you the distance. And of course, you had to add up all these little rectangles. We're going to make them so tiny that it actually just shades everything in. And so, what's the difference between distance and displacement? If you integrate your velocity from t1 to t2 of your velocity function. Okay, that's weird. That was my phone, I think. Anyway, that's equal to your displacement. Now I stand here and I walk to my desk and I walk back again. My displacement is 0. So when you do the integral, because that's a signed area. That could be 0. But what about the distance? It's not 0. Right, it's 2 times the distance I actually walked. So how am I going to fix that? Now, this would be a calculator question. It would be the antiderivative from T1 to T2, but we would have to do what with it? Velocity. Absolute value. That's what your distance is. Your displacement is the integral. So it's kind of like a vector. So if I walk all the way to the office and back, my distance is not 0. My displacement is. Displacement is where you end up relative to where you started. Distance is the actual distance you travel. But generally speaking, unless you know how to graph the function, it's a simple function, it's not going to be a problem. What is the integral of f prime of x dx? What's the integral of the derivative? Adam, what's the integral of a derivative? It's the original function. And then what do I have to add when I do this, when it's an indefinite integral? Plus c. We don't have a lot left. In Chapter 6, we're going to do more with antiderivatives, the complicated ones. These are the simple ones with composite functions. And we're going to do what they call differential equations. And if you don't put the plus c in those, and they're almost always on the free response questions, it's the easiest 5 points you can get on the exam, but you need to prepare, you need to study, you need to practice. But it's not that bad to do. But if you don't put c in, you're done. Okay, Adam. I'm expecting a perfect score. Because you're paying attention so well.
Yeah.
Okay. Average value of a function. Where am I at here? Yeah, that's right. How do you find the average value of a function? I'm going to put an A here. Now, what is the average value of a function? Adam. Put that away, please. It's all the y values added up, divided by how many I have. I'm averaging the y values. I'm averaging the heights of the function. So, how do you add them up? That's what this does. It adds them up from a to b of f of x dx. And then what do? Divide by the length of the interval. That's how many numbers you have. Do you realize that's the same as this? Those are the same things. Yes? Good question. What is this? If we take capital F as any antiderivative of little f of x, and I think I would like to actually maybe let's just put this up here for a second. I'm sorry, what did you say?
That's how you find the average value.
Right. What's the antiderivative of little f of x? Big f of x, right? Evaluated at b minus f of a. I'm using the fundamental theorem of calculus. What does that look like? Looks like slope. Just wait. Just wait. So this is f of c average. This is the mean value theorem for integrals. That's the third derivative. Okay. Now, 3b, what is the average rate of change? Now, if you read the problem too fast, this is going to be a problem. You got to slow down and read all the words. The minute you hit average, it all depends on what you have. But the average rate of change is f of b minus f of a over b minus a. Look at that. It looks the same, doesn't it? Almost. Different function. One's the antiderivative. Do you remember, this is the mean value theorem for derivatives. So this is equal to what? The average rate of change somewhere on the interval has to equal the instantaneous. So that's f prime of c. If I were to take the derivative of my integral one, this would be f prime of c. That would be little f of b minus little f of a. It's the same thing. This is the integral form. That's the derivative form. There's your derivative. There's your antiderivative. I think that's kind of cool. We will connect it more with velocity and position later on when we review. That's when things really come together. So you need to know average value of a function and average rate of change and the difference. Some last quick little things. What if I want to find the antiderivative of even and odds? What if I wanted to do this, and this is odd? It's 0, because if it's an odd function, you know, something might be over here, and I want this area and that area, they cancel out because it's odd, yes? So if I ask you to integrate from minus pi to pi of the sine of x dx, what's that answer? 0. What if I add, and you could do that one, and you could figure it out, you'll get 0, Adam. Or what if I integrated this one? Sine of x to the 11th power. Now sine is odd, and the 11th power is odd, it stays odd. It's still 0. You can't do this one. You can't integrate it, though, and check it out if you want. The other part of this is, what if I integrate from negative a to a of an even function? Right. You double the area. Oops. Starting at 0 now. It usually is just easier in terms of computation to have it go from 0. This one's equal to that one. Is that okay, Natalie? Yeah. Okay. And there were some, you know, properties. Make sure you know your properties. Like if you want to add up a to b plus to add up b to c, that's the same as adding or integrating from a to c. Okay, on this yellow sheet that you got last week, if you don't have extras, it's a summary of all these little things on here, things you need to know. Well, it's kind of open-ended, but it just gives you basic things that you need to know. That's what, if you know this, you know what's on there. Probably you have to apply it. Okay, and the last thing is if you can use geometry, use geometry. Antiderivatives are hard. You could have Riemann sums. What's a Riemann sum? The Gorlewski sum. That was a good answer. But you know what they're going to do? It's just the area, and they're going to say, using a Riemann sum, they're going to say find the area using 3 rectangles or 3 trapezoids. It's all geometry. Nothing fancy. I'm kind of glad we don't do the fancy stuff because then you get it confused with the fancy stuff. So when I'm looking at the geometry stuff, and if I look through this free response packet that hopefully you guys tried, and the answers are all online, you have to look for them. I didn't make a separate answer key. 2003 is there. Yeah, well, the scoring rubric. So do you want to look at 2003 Form B? Is that the one you want to look at then? Yeah. This one right here? Yeah, let's go. We can do that. But if you look through the pictures, you should always look, when you get into a free response question, you guys, hey guys, when you get to a free response question, quickly read through it and see what it's asking. Look at the pictures. Make sure they're giving you, that you recognize what they're giving you. Is it a derivative? Is it the function? It's usually the derivative. Okay, Adam? It's usually the derivative. So I don't want you to make those mistakes. Okay, so actually I have this one. So I don't have to go and find it. Is it that one? Nope. Trying to find it. Maybe I don't have the right ones here. Oh, oh wait, there it is. It's not in the right order. Okay, you have it in front of you. Okay, read through it carefully. I see geometry. I'm looking at that and, oh, triangles. It's not going to be hard, is it? Okay, let that be a function. It's on a closed interval. Closed intervals are good because I can have the mean value theorem, intermediate value theorem, max-min existence theorem. There's not that many theorems you have to know. I think there's like 5. Okay, they're made up of line segments, as in the diagram, and g of x is the antiderivative. Now, when I see that from 2 to x, it's asking you to find the area starting at 2 and going to either side. If I go to the left side, it's negative, so I have to watch it. Okay, and if I don't know what to do, just start doing what it says. A says find g of 3. G of x is equal to the integral from 2 to x of f of t dt. So what's g of 3? Does anybody need a copy? Oh, you have it. Okay. This is on the 3rd page. It's the last page, actually. It's the last problem. This is 2003 question 5. I'll have to fix that then. Okay. And what is this? It's the integral from 2 to what? 3. And of course you know that an integral, if I knew what the function was, I could find the antiderivative. Oh, the x's are over here. I could find the antiderivative, but I don't know what the function is. I suppose I could write it. I don't want to do that. It's easier than that. I just want to find the signed area from 2 to 3. What is that shape? It's a trapezoid. So this is the height. The height goes from 2 to 3. Okay, so what's the formula for trapezoid? 1/2 height, b1 plus b2. And if it were complicated, this one's not complicated. If they were doing trapezoidal rule, you'll get some points for making an honest effort. But this one's not that complicated. This height is 1. You could do triangles if you'd rather. And it's this base, which is 4, and plus this base, okay, Natalie, which is plus 2. What is half of 4 plus 2? 3. 1 point. And I make mistakes, so watch it. Then it says to find g prime of 3. Now, they didn't directly say find g prime of x, but it seems like that would be a smart way to do it. G prime of 3, and you get the point for knowing what g prime of x is. So if g of x is equal to this, then if I take the derivative of that with respect to x, do you recognize it? What is this? The second fundamental theorem of calculus is part 2. What is this equal to? Adam?
Equal to
times the derivative of x, which is 1. So you get a point for saying, we're just saying g prime of x equals f of x. Somewhere on that scoring rubric, they should give you that point. So g prime of 3 may not be in this section, it might be in the next part, but whatever. Equals f of 3. What's f of 3? Yeah, 2. Usually the Form B ones are a little bit harder than the regular ones. You should be doing it with me. Not watching. Where?
I didn't write it all out.
You need to practice writing it all out. Okay. What's G double prime of 3? Well, what's G double prime of X? I'm going to take the derivative of this one. It's F prime of X. G double prime of 3 is equal to the slope at 3. Slope at 3 is, let's see, this is 2, and this is 4, so it looks like it's a negative 2. Okay, that was A. My guess is 3 points. Find the average rate of change, not the average value of the function, the average rate of change from 0 to 3. How do you find average rate of change? It's the what? It's the slope. It's just the slope using those endpoints. So I'm finding G of 3 minus G of 0, all divided by 3 minus 0. And remembering, when I look from 0 to 3, the mean value theorem will not apply. Because this is, well, it doesn't apply to this one. It could apply to G. Not thinking right. If you tried to do the mean value theorem on F, it would not apply. Okay, so I want the area from 0 to 3. Okay, what is, I want that right there. Not area, I want slope. What's G of 3? We just did that. 2. And the other reason to practice doing this, you are limited on your time. You want to practice how you do that. Now, G of 0. Is it? Careful. G of 0 is equal to the integral from 2 to 0 of F. So G of 0 is the area from 2 to 0. It's this area. But what's wrong with it? It's negative because that's in the wrong order. And so it's 1/2. The base is 2, and the height is 4, right? So that's negative 4. All over 3. Question. See why it's negative? Pardon? No. The slope is 2. I want the area. The integral is the area. Yes. I have to find G of 0. G of 3 we found in part A. That was, did I copy it wrong? I did. That's no problem. Is the copy error? No, that's not really clear it's a copy error, so I probably wouldn't get the point. But if it's clear you just copied it wrong, then you'd be in trouble. Then you'd be okay. No. But this one I might be in a little bit of trouble. But, you know, if I write it out like this, the way I have it written, my intent is clear, and I miscopy this, I think this took me the point. Because I clearly have G of 3 right here. And I clearly say I want to substitute in G of 3. Obviously, I just miscopied it. So, 7/3. That's a judgment call on your reader. And if that were me reading that, I would be taking it to my person who's sitting on my partner and say, what do you think? I think it's just a copy error, and then we agree together. If we can't agree, then we go to the table leader, and we ask them what they think. We'd be like, we're all in here, and we're all grading, and I'd be your table leader. So you're grading, and you have questions, you come up to me. And if I can't answer that, then I go to the question leader. The question leader is the one who did all the scoring for that question, who decided where the rubric and where the points would go. And if the question leader doesn't, and they have a team, it's not just one person. If the question leader and their team can't figure it out, then they go to the chief reader. Then it doesn't get to him very often. Let's get to the question leader, so. It's one guy, he is a reader, he's the chief reader for 3 years. I'm just the reader. Okay. Now, I forgot the question after all that. Okay. Okay, for C, how many values is the derivative at C equal to the average rate? Now, by the mean value theorem, there has to be at least one, provided that H is differentiable. And HG. Okay, so I want G prime to equal my average rate of change in B. And G prime is f of x. So I want to know how many times f of x is equal to, because this is G prime of x, is equal to 7/3. That's 2 and 1/3, right? Where's 2 1/3? How many times does that intersect? Twice. There's two values, this value and that one. It's the mean value theorem. Pardon? That's a good question. I'm thinking about that. That's a tricky one. How many values? Is to explain your reasoning. I would say that by the mean, I would actually use mean value theorem. That G prime of C has to equal my average rate of change. It wouldn't apply to the function, but G it can apply to. G prime is f of x. F of x is clearly defined. F of x is not, there's no discontinuities or anything. That's okay. Because G is differentiable. And I get it. What if we wanted to apply the mean value theorem to f? Then we couldn't do it because f is not differentiable at those corners. Okay, so this is equal to the average rate of change, therefore 2 times. We'll have to go and look at the scoring rubric. I don't know how it's going to be graded. I don't always get full points. Get pretty close though. Okay, D, find the x-coordinate of each point of inflection between 0 and 7. Okay, I'm going to justify my answer first because that's how I'm going to figure it out. How do you find inflection points? It's where G double prime of x changes sign. And so in terms of my graph, what is that? G double prime of x is equal to f prime of x. So I have to see where f prime of x changes sign. So it's the slope of f at, now let's see, where does this change sign? Right here? It's positive here, negative, stays negative. It's a sharp corner, but doesn't matter. It has to change sign, and at 5. Yeah, this is the only problem with this. Yes, that was this one. That's C. But did I not label it? I'm pretty sure that was C. I just didn't label it. I'll fix it. So I'm going to go and find, well, I can do it here, the answers. We got them back last week. Yeah, you corrected them. No, we didn't. You corrected them Friday. We got them back Friday. I haven't put them in yet. Okay, so I'm going to do it this way.
Just going basket for tomorrow. Should we just like finish up this packet?
That would be a good way to study. Make sure you know everything. Let's see. This is 2003 B.
This one, Bugsy, how much do you get paid for grading? Is that a percent?
It's not that much though, because I make more being a consultant. But it's okay. Gives me some money in the summertime. What number was this? 5? There it is. Okay, let me make it bigger. Okay, let's see what we got here. We got 3, 2. Did we get -2? Yeah, didn't we? Okay, 1 point each. Can't everybody here get that? Say yes. And we had 7/3. We got that right, too. You got 1 point. Forget how they wrote it. The way we did it was fine. 1 point for this. They wrote it with the calculus. You're just not that as familiar with it, so it looks weird. But the way we did it was fine. And there are, now, the question was, how are we justifying C? So if you do use the mean value theorem, you probably would get it, but you get 2 places. And you would just say the graph intersects the line there. And I would include mean value theorem. This was 2003. I think they're pickier today. I would include mean value theorem. I got full points. I would have even written that about the graph. And then 2 and 5, the justification. Now they do F prime or G prime, increases, decreases. Second derivative, going and changing sign is the best way to do it. They don't like when they do that. And by the way, if you talked about 4, right or wrong, we would ignore it because that's what it says. So, you want to do another problem together?
Sure.
Or work on your own. We have about 15 minutes.
Let's do 2007.
I would. Oh, that's not the one I want. Oh, no, yes, it is.
We should do the 2007 form machine. Like on the very front, question 4. Working on it right now. C is kind of tricky.
I gotta find it. That one?
Yeah.
Okay. Should be easy. Mhm. I think we should do the whole thing, don't you guys? Hey guys. We got less than 15 minutes, so we're on the exam. Let's get this done, right? I want a maximum on here. Now I better read the questions. I didn't do that. Okay, shh. F is defined on a closed interval. Hey guys, shh. F of 1 is 3. Don't forget, I'm here in the morning. Come in, work on problems. Right here in the morning. I don't have it on the graph. That's not F. What is that a graph of? F prime. So you can't bring highlighters in. Like, that would certainly help you if you could highlight it and say, oh, this isn't the function. Okay, Matt, Julian. Okay, I want to find all values where F has a maximum. I'm going to justify my answer first. F has a maximum when F prime does what? No, not a sign change. Goes positive to negative. Question in the back? So where does the derivative change from positive to negative? Not the slope of this curve. At -3. Now it's going to go negative to positive. That would be a minimum. And then over here at x equals 4, it goes positive to negative. That's all you have to do. That's my justifying. On the same interval, find all values of x at which the graph of f has an inflection. Justify your answer. I like this problem. I have not done all the Form Bs. And there's also a makeup test, and I've never seen one of those. So if you have a conflict, and some of you may have a conflict that day, I'm trying to think of what conflicts. Super challenge or something like that. If that's a conflict, you'll have to do the makeup one. Please let me know if you're in that situation. Okay, inflection. How do you find inflections? F double prime. Change of sign, right? That's the slope of my graph here. When the slope of this graph changes sign, so second derivative. Okay, it's positive, negative, so I see -4. Stays negative. Now it becomes positive, so -1. Stays positive, and at 2 it changes. Doesn't matter that that's undefined. That's if This derivative is 0. That means it's going to be smooth. If it's undefined, it's probably going to be sharp corner. Okay, that should be right. I have it. I have it. Okay, C. Find all intervals on the graph of f where it's concave up and has a positive slope. So let's translate that into calculus. If it has a positive slope, f prime is what? Positive, greater than 0. I'll do it this way too. If it is concave up, f double prime is positive. Okay, so I'm going to have to look at where, and it might help me to actually draw the little graph. I'm going to do that. You get no points for this. This is f prime. Now, f prime goes from positive to negative at -3. It's positive, negative until I get to 1. Then it's positive till I get to 4, right? And then it's negative. Okay with that? Now let's do f double prime. I mean, I could talk it through, but it's easier if I do this to see it. F double prime. Where is f though? This is the slope of this graph. It's positive till I get to -4. And then it's what? Negative until I get to -1. I'm trying to line it up a little bit. And then it's positive until I get to 2. And then it's negative. Okay, so I just have to look at this. I want it positive on both graphs, so that would be here. So it's -5. Don't do negative infinity because we don't know. To -4. And you're going to union these, but they don't get picky about that. And then this is positive, negative, this is negative, negative. I don't get to both positive until I get to 2, right? No, between -1 at 1, right here. It's positive until I get to 2. And that's from 1 to 2. And then it doesn't work after that. Okay? That help your question?
Yeah.
I don't know if this helps or not. Otherwise, I have way too much stuff going on in my head. Okay, what's positive here? I might double check it. So -5 to 4, this is positive and its slope is positive. At least that answer works. I may have more. I might be missing something. And from 1 to 2. 1 to 2, this is a positive graph and its slope is positive. Okay, what's the last thing? Find the absolute minimum value on the closed interval. Okay, we know where the derivative changes sign, right? Where's our minimum? Let's go ahead and put this in right here. There's a minimum where? At x equals what? 1. So that's a candidate. I know that's a max. I'm not even going to consider it. I know, I might get in trouble. So I need to find f of 1, f of 1, f of -5, and f of 5. And you're going to say, how do I do that? How do you find f of 1? They gave us a nice pretty picture. What is f of 1? Oh, it's 3. They told me that. It's 3. Okay, what's f of, now that's this. Now this is the derivative. Now this is hard. How are you going to do that, Adam?
By using the...
I'm going to use the fundamental theorem of calculus that says that the integral of f prime of x dx from a to b is equal to f of b minus f of a. This is the hard part. To find f of -5, I'm going to integrate the derivative from a value where I know what it is, because I'm going to have to find the antiderivative. Well, I know what f of 1 is, so why don't I integrate from 1 to -5? This is worth at least 4 points on this problem, I'm going to guess. So that's equal to f of -5 minus f of 1. If I solve for f of -5, and unless you practice writing it out, you won't be able to get this done quick enough on the exam. It's f of 1 plus the integral from 1 to -5. What's f of +5? It's f of 1 plus the integral from, what do you think? 1 to 5. That one's easier. Let's go in the right direction. Unfortunately, this one's not. This one is f of negative 5 is equal to f of 1, which is 3, whoops, minus, I'm going to switch the order, negative 5 to 1 of f of p. Okay, so I just have to find that area. Be sure you use parentheses, but don't bother simplifying. So negative 5 to 1. Positive 1? Yeah. Okay, what is this? It's half of a circle of radius, what? No. It's radius 1. And then what's this? And what on this? It's, what's the radius here? 2. So it's minus 1/2 pi 2 squared. I'm going to substitute that in. Do I have to have those parentheses I had? Yes. So it's 3 minus, and that was pi, half a pi, right? Minus, and that was 4 pi, right? Go back up. Oh, so it's just going to be 2 pi. That's a fine answer. If you don't want to do any more with that, don't. Because if you do more with that and get it wrong, you're wrong. What about f of 1 here? This is 3. And the area from 1 to 5. 1 to 5. Okay, I've got this little piece. What's going to happen? Well, it's probably just easiest to do this. It's 1/2. What's the base? Nope, it's 3. And the height is 2. And then we have to do minus 1/2. What's this base? 1. And its height is 1. So it's going to be 3 minus 1/2. Leave it. It's good enough. Because ask yourself what they're asking. They're trying to find out if you know the calculus, if you know how to solve the problem. They're not trying to find out if you know arithmetic. They already did that part. They did that on the multiple choice. Because you got to match your answers. So we did a lot of these problems. And we'll have to look up the answer. This was 2007B. Oh, this is just being fussy. I've had problems with my smart board today. Yeah.
When is the math testing room open?
It's open every morning, like at 7.
Every morning at 7? Is
Yeah.
it ever open after school?
Yes.
What days is it open after school?
Every day but Friday.
Okay. Because I'm going on the courage retreat tomorrow.
Right.
But I can't do the test on Thursday because I'm doing singing telegrams.
Oh, okay.
So, could you just like put it in the testing room for me?
Yes.
Okay.
Okay, on part D, you got a point for considering the endpoints. And we forgot to answer the question. Which one's the minimum? Because f of 1 is equal to 3. Now, notice that I know you guys want to go, but it says, wait, find the absolute minimum value of the function. Guess what? They don't want the x-coordinate, they want the y. Okay, time to go. Bye.
You guys,
Yes.
that first one, it says I have a score there for the initially by the way to
Actually, maybe.
I thought I put the corrections.